Hello everyone. So in previous videos, we covered the meaning of a binary semaphore, the code design pattern, and how a queue of one item with 0 byte payload can be a replacement for a binary semaphore. This video, we're going to focus only on, how can a consumer consume multiple signals even though it's a binary semaphore, and we're going to achieve that by making it a higher priority. We're going to defer for other videos counting semaphore and other binary or other semaphore families members like mutex. Unlike my previous videos on the binary semaphore, I've changed my example to maybe make it a little bit more realistic. So I have, let's say, a producer 1, and maybe an example is it's a button press. And the idea is a button presses, it's going to give an indication to the LCD updater task to update the LCD. In parallel to the button press, you may have another event of some kind which says that some event happened and it also needs to update the LCD. Now, if a button presses, you need to update LCD, and another event happened and you need to update LCD, and for the sake of simplicity, let's say that you do need to update LCD twice. So one thought process you can have is that, hey, like it's a binary semaphore. If two guys give the indication, it's not going to update the LCD twice, but maybe you have an example where you do want to update it twice. So what will happen right now is, what I'm going to do is deliberately the button press example and another event example, they are higher priority, so they're going to run first. And if I run this project, you'll notice that one of them, let me kill this program. You'll notice that one of them was able to send the semaphore, and the other one was not able to send the semaphore. Let's see which one did and which one didn't by adding an else statement. Okay. And here I will add else statement and say, another producer sent the semaphore successfully. And I'm only going to send these signals once and take a long pause. And let's study the output. Okay, so we noticed that these were both equally high priorities, but only one will be successful because it's a binary semaphore. So in this case, the way the FreeRTOS ran the code is that another producer sent it successfully. So this guy was able to send the semaphore successfully, the binary semaphore, but this guy was not able to. So that's why we received this error message that, that's why we received this error message that not able to give the signal. And I think I can maybe be a little bit more robust here also. You can call it error for button press and error for producer 2. Let's run this one more time so it's very clear. Okay. So the button press one was not able to give the binary semaphore, but the other guy was able to give it. And that's again because based on the previous video, you learned that it's a binary semaphore. So the LCD would only update once. But what if you really need to make sure that this LCD processes both of these signals? So what you could do is you can structure your priorities so that the producer is higher priority. So that means as soon as anybody gives the binary semaphore, you unlock another task of higher priority and it will immediately run and consume it. And then the producer 2 will come and it will give us a binary semaphore and the other guy will immediately run and consume it. So the context switch happens inside of this API. A cooperative context switch happens inside of X semaphore give API, where it does a software interrupt and context switches over to the other consumer and starts to run it. So now let's run this and study the output. So notice that now both of them said that they were able to successfully send the binary semaphore, and we received two indications that we updated the LCD. It almost happened, it happened back to back. So both of these guys gave their semaphores back to back. And more importantly, before they were even done exiting out of this function, FreeRTOS immediately context switch over to this consumer, because consumer is higher priority. So if you have an application where your consumption should be immediate and there may be multiple producers of a binary semaphore, you can use a higher priority on a consumer, so it will immediately consume the new binary semaphore as it comes. And therefore, we don't need a queue or a counting semaphore. In this video, we're able to show how a binary semaphore can still be used to capture signals from multiple producers, as long as consumer is the higher priority. Thank you. And any questions, you can drop them in, and we're happy to follow them up, answer them, and also create further videos.